This week we're going to look at parts of Chapter 5, okay, not the whole thing. We're going to focus on Section 5.1 and 5.3. In the middle, we'll kind of take a little break and review a section in the back of the book that'll help us to do some stuff in 5.3, but without that review, I think some people might be a little shaky on complex numbers. So we'll take a look at that. All right, so we're going to look at what's called polar coordinates. Basically, what we're going to do is we're just going to be graphing single points. Okay, we're not even going to be graphing like a whole picture. Okay, we're just going to graph coordinates in this section. So when you have the kind of graphing you're used to, like x-y axis stuff, you can graph things like lines. So that would be a line with a slope of 3, y-intercept of 2. You can graph something like that. That's a parabola. You can graph all kinds of different things, just to look at a couple. But the kinds of graphs that you do in y equals are always functions, meaning if you draw a vertical line through those graphs separate, not at the same time, but just look at just the red graph, for example. If you put a vertical line, it would only hit it one time. If you look at just the blue graph, wherever you put a vertical line, it only hits it one time. That means it's a function. Well, when you start getting into polar graphing, we can graph all kinds of different things, like a circle. That's not a function, because if I put a vertical line, it hits it more than twice. That's something that you can't easily do in the other mode, like y equals. Okay. We could also graph something like this. We could graph a spiral. Again, not something that's easy to graph in y equals. We could also get really fancy and graph something like, let me zoom in so you can see it. Graph something like that. So it's like a flower petal kind of thing. Again, not the kind of stuff you can do easily in y equals. Okay, you really need polar to do this kind of stuff. Okay, so some of those graphs are a little bit beyond what we're going to do, but polar is a very nice coordinate system for graphing things that you might think would be hard to do, and it actually makes some graphs much, much easier. Something that's kind of hard to do in polar is a line. Okay? Lines are very, very simple, and the best way to do a line is y equals mx plus b. I can do a line in polar, but it's more complicated. Okay? Polar is really good graphing for things that are curved. Spirals, circles, petals like that, that's what that's called. Things that curve. All right, so we'll start out with just the basics and what you call the axes in polar and how you graph single points. All right, so this is just the kind of stuff you've done before. You've graphed with xy coordinates. We're going to look at polar. You really don't need to write that down. Okay. First big difference in polar is that the graph paper is not rectangular. It's not a grid. It's more of these concentric circles. Okay. And just to show you like a real piece of graph paper, that's what it would look like. So in place of the x-axis, okay, they call that the polar axis in your book. Also the center point. In polar, you could call it the origin, but a lot of times they call it the pole. And the way you label around the circle, you label it in degrees. Okay, so in polar, it's not necessarily moving left and right and then up and down. That's x and y axis stuff. Okay, left, right is x, up, down is y. In polar, part of your coordinate is going to have to do with an angle. Right, so on the positive x-axis, you have 0. Positive y is 90. Continuing counterclockwise, 180, 270. So a polar coordinate, okay, which is much, much simpler than what I was showing you. I was showing you a graph on the calculator. Okay, a graph is when you take thousands and thousands of points and put them all together at the same time to get a picture. Okay, this is just a single dot. And polar coordinates have two parts to them, just like an xy coordinate. And the two parts are a radius and an angle. But the movement is a little bit different than x and y. It's not going to be left and right and up and down. One of them will be left and right, but then the other motion is more circular motion. A motion on a circle. All right, so there's really two things you have to look at when you want to graph a point and polar. The first thing is you look at the radius. And what you do is you start, I just scroll back up, you start at the pole, and you move out the number of circles, or the number of rings indicated by the radius. Just like an xy coordinate, you can move out like 1.5 rings. That would mean I would move out like right there. So you can go in between the grid circles. Okay, so move out the number of rings indicated by the radius. Just like in xy coordinates, though, your radius can be positive or it can be negative. And the nice thing about the radius is it follows the same rules as the x coordinate. Theta is totally different. Okay, that doesn't really have any connection with the y coordinate. But r is kind of like x in rectangular coordinates. So if r is positive, okay, if you have an r value greater than 0, you're going to start at the pole with the origin, and you're going to move right. Now, that's not the final answer. Just like when you're graphing a coordinate like this, you start by going 3 to the right, but that's not the answer. You still have to take into account the second number. Right? You're still going to go up 2 in that case. So after you move for r, we still have to take into account theta. You still got to deal with the angle. We'll deal with that after. So if r is positive, you start by moving to the right. What do you think you would do if r is negative? You would move to the left. So if r is less than 0, you move to the left. And Mr. Babb and I actually had a little discussion about this morning because he's doing something with this in calculus. And the idea of how can a radius be negative? Because radius is a distance. Right? If you're measuring a distance, it doesn't really make sense to have the radius be a negative. I don't have a terrific answer for you, other than if you follow these steps, it works. All right. So if your radius is a positive number, consider it to the right. If it's negative, think of it as going to the left. I guess one way to think of it is don't think of, like if you had a coordinate like this, that's a polar coordinate. Don't think of it as a -3 radius. Think of the negative as a direction. Like if positive means you go right, negative just means you go left. Okay, it's not that it's negative distance. The negative is just telling you left, where a positive tells you right. So if you think of it that way, then you don't have to think of it as negative distance. But I mentioned that to Mr. Babb, and he still wasn't satisfied, so I don't know. Don't think about it too deeply. All right, so now once you've moved left or right, now you have to look at the angle. So the angle is motion on a circle. What are the two directions you can move on a circle? Like if you're traveling. You don't really say up, down, left, and right for circular motion. Clockwise or counterclockwise. So those are the two directions you can move. One of them is going to have to do if it's positive, one of them will be if it's negative. So if your angle is positive, that's counterclockwise. It's positive angle, you go counterclockwise. Negative angle, clockwise. Okay, so look at R, decide if you should go left or right. From that point, look at theta, and then decide if you should move clockwise or counterclockwise. Okay, your radius is always just a number, but your angle could be a number in degrees or it could be in radians. If it confuses you when it's in radians, then change it. Change it to degrees. If you don't need to change it, don't change it. Okay, whatever unit is easier for you to work with, that's what I would probably use. Right, so now we'll just practice graphing some coordinates. Okay, we'll try all different combinations, like where the radius and angle are positive, where they're negative, one of each. Okay, we'll try all the different things. All right, so Haley, what's my radius here? My radius? So you're looking at that coordinate, right? 3. So my radius is 3. Peter, since the radius is positive 3, do I go left 3 units or right 3?
Right.
I'm going to go right 3. So I'm just going to put a little mark there, because that's just where I'm going to start. I'll erase it in a second. But that's where I'm going to start from. Okay, so I went right 3. And now I need to move 120 degrees. So Eric, is that going to be 120 degrees clockwise or counterclockwise?
Counterclockwise?
Yeah, how come?
Because it's more than 0.
Yeah, because it's more than 0, it's positive. So on this particular grid, I think each line is 15. So that's 0, 15, 30, 45, 60, 75, 90. All right. So to go 120, I got to go all the way to 90. And then I got to go 30 degrees past it, which on this one is two more lines. So I would be right there. So that's right 3, and then left. I'm not going to keep that on this one, but I'm just showing you the direction I went to get to that point. Right 3, counterclockwise 120. Okay. Any questions on that one? Well, that's it. That's how you graph a point. Okay, let's try 5 comma pi over 4. Paige, what's a little different about this one? Both the radius and the angle are still positive, but something's different. Yeah, the angles and radians. So if we want, we could change it to degrees if that's easier to graph in. Molly, do you remember what pi over 4 is in radians? How about pi? Do you remember pi? Well, as a decimal, yes, but how about if you convert pi to degrees? Yes, it's 180. Well, this is pi divided by 4, so it's 180 divided by 4, or half and then half again. Not sure, anyone help out yet?
45.
45. Okay, so this is 45 degrees. And then we graph it. Connor, can you tell me how I'd graph that one?
You go to the right 5.
All right. So I'm going to start right there.
And then you go like halfway between 0 and 90.
Yeah, and which direction is that?
Counterclockwise.
Good, counterclockwise. And like Connor just said, it's exactly halfway between, which on my grid they put it as a red line so you can quickly find the angle that's halfway between. That's it. Any questions on that one? Okay, so we've done a positive now as both a radian and a degree. I'm not going to do every single other one that we could do as both radians and degrees. Okay, so let's try a positive negative. This time I'm just going to do it in degrees. Okay, so 5, negative 210. Okay, so Robin, what's my radius there?
5.
5? So how do I graph that part on the grid?
Just move over 5 units.
Can you be more specific?
Move to the right?
Yes, move to the right. So we're going to move to the right 5 units. And now, Alex, my angle is negative 210. So what way do we move for negative?
Clockwise.
We're going to move clockwise. Well, if we went halfway around, how much is that? That's 180. And then how far past 180 do you have to go to get to 210? 2 lines. You have to go 30 degrees past 180, because 180 plus 30 is 210. Okay, so we're going all the way halfway around, and then 2 more. And that's that one. 5, negative 210. Any question on that one? Okay, so positive, negative. Let's try negative, positive. Okay, so the radius is negative 3, but I'm guessing on this one, people might want to change the angle again. Anybody tell me what pi over 2 is, right? 90. Okay, so we've got negative 390. Ryan, can you tell me the next step to graphing that point?
Go to the left 3.
Yes. We're going to the left 3. Now, whenever you move from here, everything is relative to that. So that's like 0 now. That's my starting point. So now I'm going to move 90 degrees. It's positive. So that's counterclockwise. So where am I going to end up if I move 90 degrees counterclockwise? Ashley?
Would you end up at the 270?
Yeah, we'd end up, if you were going in the positive direction, what we would normally label as 270. You know, if we had a positive radius, 270 would land right there. Well, if you have a negative radius and a 90, you land right there. Okay, for this one, I'm going to draw how we got there. We went left. That's how we got there. Can anybody give me another coordinate that would get me to that same spot? Yeah.
3, negative 90.
3, negative 90. Yep. I think that'll work. So that would be right 3, negative 90. That would be going that way. Can anybody give me another one? Yep, Alex?
370.
All right, 3, 270. And we heard that idea come up earlier when I asked where would you end up. Somebody mentioned the idea at 270. So you could do 3, 270. So that would be right 3, all the way around that way. I drew it off the black line a little bit so you could see it. And there's one more. I think they know the last way. Yeah.
Negative 3, negative 270.
Yep. So we have negative 3, negative 270. So that's left 3, negative 270. So the idea there is there's 4 basic ways to get to every point in polar. Right? Both with positives, both with negatives, and then one of each. Negative, positive, positive, negative. And that idea is a little different than Cartesian. If I bring up just a regular Cartesian grid, and I put a point there, and I said, how do I get to that point? What's the coordinates for that point? Yeah.
2, 1.
2, 1. Can you give me another coordinate for that point? What do you think? Zach? No, there is no other coordinate. 2, 1 is the only way to get to that point. So in rectangular, if somebody gives you a location and wants to know how to get there, there's only one way. In polar, there's 4. Now, technically, you could say there's an infinite number of ways, because you could say, well, what if I go right and then just go around an extra time or 2 and then stop. Well, that's just kind of a repeat of one of the 4 basic ways. Right. So I don't consider making extra revolutions a different way. I think there's 4 ways because you can go right clockwise, right counterclockwise, left clockwise, left counterclockwise. Those are the 4 ways, regardless of how many times you go around. Okay, any question on that? The reason that's important is because when you solve a problem, you might get an answer to it. And if it's a multiple choice question, maybe when you solve it, you got that answer. But on the test, I wrote that answer. So you just have to understand that those 2 answers are the same thing. I think the easiest way to figure it out is just to draw it. You could probably come up with formulas. Like if you had the positive, if you subtract 360 from the angle, that gives you the negative. And you could figure out all kinds of rules to do it. But I think a sketch is probably the easiest. Right, so we actually did this in the one we just did. We did a negative, but let's try one more. So Irene, can you tell me how I would graph that one?
Go to the left 2.
Yep, left 2. So we can start here. All right.
Then you go clockwise to 0.
Yeah, we're going to go clockwise 180 degrees, which, if you wrote that as a positive radius, would land you right at 0. Okay. So left 2, clockwise 180. Now, what if I change the problem to that? How would my answer change? If I get rid of that negative in front of 180. It wouldn't. No, it would be the same problem. Anytime your angle is 180, it doesn't matter if it's positive or negative, because you're going halfway around, whichever way you go. Okay? And since we're just plotting a point, I don't really care about the direction you went to get there. I just care about where the final answer is. Okay. Any question on that one? That's a negative. All right, let's try this one. 0, 300 degrees. Anyone think they can tell me where that point is going to end up? Your radius is 0, but your angle is 300. About Emily? Any thought? You can graph it. It'll end up somewhere. So the first thing is the radius is 0. So how would you start with just that part? Yeah, it would stay at the origin. Right? Normally you go left or right the number of units indicated by r. This time you just stay right at the origin. And now what about the 300? Yeah?
Since it's in the center, would it just not really turn that much? Or just stay in the center?
It's just going to stay at the center. Yeah, it's basically going to pivot right at the center. So that's what you get from doing a radius of 0. But then you have to take that and you have to pivot it 300 degrees. So just take and pivot it 300 degrees. Yeah, I didn't want to pivot everything. But there you go. Make sure you pivot it just like that so I can see that you turn the point. That's important. You gotta see the pivot. Okay, I don't have to see the pivot. Yeah, it just pivots in place. So basically, anytime you have, let me put this back, 0, any number of degrees, it's always right at the origin. How about this one now? I put the 0 in the other spot. Is that going to end up at the origin? No. This is always going to end up on a horizontal line. It'll always be on the polar axis. Okay? What we called the x-axis before. In this case, it's just 1 unit to the right, and you don't move at all. Okay, what if I did this? Where would that one end up? It would be the same thing. Based on what I said earlier, would we consider that a different way to get to that point? Ready? No. It's still a positive positive. Okay? Whether you go to the right or you go to the right, you go around extra times, you can add 360 as many times as you want. You're still stopping right there. Okay? The only way we could do that in a different way is if you change the signs here. So you could make it a negative one. Okay. Any questions on that one? Okay, for this particular point, I think you could only write it 3 different ways. Because you could go right, but the problem is you can't go clockwise or counterclockwise because you're stopping right there. Okay. The other ways you could do it would be left, that direction, left, that direction. So there are only 3 ways to write that particular point. All right, let's look at this one. So I'm giving you a point. And I want you to try to write it 3 different ways. So the easiest thing might be to make a sketch and just draw it out and see how to get where I want you to go. The first way I want you to do it is with a positive radius, and I want the angle between 360 and 720. So this is a problem where I am asking you to go around an extra revolution. I would just like to see how to write it that way, okay, like I did in the last problem. Okay, the second way I want you to write it is with a negative radius, and I'd like the angle between 0 and 360. So we're not making any extra revolutions, but we are going to start with a negative radius. Okay, and then the third way, we're going to go back to a positive radius, but I want the direction to be switched to clockwise. Okay, so the angle is going to be between negative 360 and 0. Okay, so what I would do is, if you're not sure what that is in degrees, I would figure that out first, change to degrees. Graph it. You don't even really need graph paper. You could even do it on blank paper, just to get an idea of where it is. And then see if you can figure out the 3 different ways to write it. Okay, so take a couple minutes, try that on your own. And, if you get stuck, I'll come around and help you out. All right, so my first suggestion, if you want something that's easier to work with in your head, I think degrees is easier than radians. So what do you get when you change that point to degrees? Molly? Yeah, you get 330. Okay, so if you want to figure out shortcuts for doing it all, like, oh, just take the angle, if you make that negative, you know, add 180, subtract 180, add 360, you could do that. Or, I think the easier way, just graph it. And now I'll just draw it on that graph wherever I have to go. All right, so the first one says I want a positive radius. Well, it's only 2 numbers you can use for the radius if you're always going to land on the 3rd ring. What are the only 2 numbers the radius can be? Yep. It has to be 3 and negative 3. If you pick a number other than that, you're not on the 3rd circle. So this time they want a number that's positive. So it's got to be 3. Now they want an angle between 360 and 720. That means I've made an extra revolution. Right? So that means I've gone this way, and I've done something like that. Well, if I make an extra revolution, how many degrees am I adding to my original point? I'm adding 360 to the original number. So what would the angle be to make one extra revolution and then stop? 390. Yep. Okay. Any question on that one? All right, so now let's do it again. This time they want a radius less than 0. So what does my radius have to be? Negative. Yep. So it's got to be negative. So I'm starting here, and now just look at the directions and see, are you going clockwise or counterclockwise? Well, it's a positive angle. So which way do I go for positive? Counterclockwise. That's this way. So now I just have to figure out how far it is. Well, on my grid, I've gone halfway and then 2 more sections. Okay, so how many degrees would that be? Zach? 210. Yep. And now the last one, let's get rid of this again. So this time we're going to start with a positive radius. So you're going to start right there, but they want you to go the long way. So you're going to go all the way around this way. So if you know that section is 30, just subtract that from 360 and it'll give you the other section. So what's my angle here, keeping in mind the direction I went? Negative 330. Okay, oh, and we didn't do the radius, but the radius is positive, so it has to be 3. Okay, so all different ways to get the same answer. Okay, any questions on that? All right, so last thing we'll look at, and it kind of leads into what we're going to pick up with tomorrow, is how we convert between a rectangular and a polar coordinate. Today, we're going to end with polar to rectangular. Tomorrow, we're going to start with the reverse. Rectangular to polar. All right, so let's just start by writing down what they give you in polar. Okay. So if they give you a polar coordinate, what are the 2 things they have to tell you? In any, yep, Alex?
Radians and angle.
They're going to tell you the radius and the angle. Now, if you're trying to convert to rectangular, what are the 2 things you have to have in rectangular? You don't want a radius and an angle. Yep.
X and Y.
You want an x and a y. Okay, so that's the goal. You have to somehow convert an r and a theta into an x and a y. All right, so what I've done here is I've drawn a point. If that's a point in polar, you would have, a grid with a bunch of circles on it. I'm just going to make one circle. So let's start with this. What is that distance that I just drew? Yeah, that's my radius. It's the distance from the center of the circle to the circumference. That's the radius. And now the angle is right there. That's the angle formed with the positive x-axis. Now we're going to turn that into a shape somehow, and we're going to use that shape to be able to figure out x and y. Anyone have a guess what shape I'm going to create there? Yeah?
Right triangle.
Yep, I'm going to create a right triangle. Can you tell me how, or do you know how I'm going to do it?
Draw a line straight down from the point.
Yep, from the point, straight down, and there's your right triangle. So remember that's your origin. Okay? And the goal is to figure out how do you get here. Okay. For rectangular, what's the first direction you move in when you're graphing an xy coordinate? You move left and right. In this case, it's right. So you would start here. I'll do it in a different color. Start here. And you'd move right. And you'd stop right there. That's your x. Okay. After you move left and right, what's the next direction you move in? Up or down. In this particular case, it's up, but it could be down. It doesn't really matter. So you'd start from where you left off. You go up. And you would stop right there. And what letter would that be?
Your Y.
That's your y. So in that triangle, if you can figure out the length of the bottom side, that's your x, and the height is your y. And you're going to be able to figure it out because they're going to tell you r and theta. Those two would be numbers. So let's start with x. Okay, I want to figure out x, and what I'm going to use to do it is theta, which will be given to you, and r, which will also be given. So now we're just really solving a triangle. We just have to figure out the names of the two sides. Can anyone tell me the name of the side we've labeled x from the perspective of theta? Ryan? That's adjacent. Yep. And Ryan, how about the side that's across from the 90? We labeled it as r.
Opposite.
Not opposite. Y would be opposite. Which one is it? It's hypotenuse. The side across from the 90, that's always the hypotenuse. So the two sides we're working with here is hypotenuse, which we will know, adjacent, which we don't know. So what trig function has those two I just said, adjacent and hypotenuse? Yeah?
Cosine.
Yeah, the cosine. So we write down the cosine of our angle equals, and what would be the fraction on the other side? It would be what over what? About, Hayden? Remember, cosine is adjacent over hypotenuse. So what side is adjacent to theta? Which one? Well, do you remember what adjacent? Adjacent means right next to. So it's one of the ones I circled, but it's the one that's next to it and not across from the 90. Are you sure, Emily? X. X is the one that I circled that's next to theta, and it's not across from the 90. So X. So adjacent over, now I need hypotenuse, r. And now the goal is to find x, so I would like my formula to say x equals. So how would I get x by itself here? Alex?
You can multiply r.
Yep.
On both sides.
Multiply both sides by r, and you get x equals r cosine theta. So there's a formula to find the x value. Take the cosine of the angle, multiply by r. Right, now we're going to come up with a formula for the y value. All right, so Orion, this time we're going to use, let me get rid of that circle if I can. And we're going to use that side. So now I circled y. What side is that from the perspective of theta?
It's the opposite.
Yep, it's the opposite. And we're still using the side that's r, which is the
Hypotenuse.
hypotenuse. And do you remember which trig function has opposite and hypotenuse?
That's sine.
Sine, yep. So I'm going to do the sine of theta. And now on the other side, it's opposite over hypotenuse. So Katie, what's going to go on the top and the bottom there?
R is going to be on the bottom and finding Y is going to be on the top.
Y is going to be on the top. Okay, and again, I want to do the same thing. I'd like to get a formula for y by itself. So Paige, what would I do to get y by itself there? Yep. Multiply both sides by r, and there's your formula for y. And now all you would do is use those two formulas. Take r and theta, plug them into the x formula, plug them into the y formula, and write your answer. So we'll try a couple examples with that. All right, so that's what we just went through. So if you've got a point in polar, They give you r and theta. Use the following formulas, and you guys just wrote those down to convert to rectangular. All you really need is what's in the box. Let's try this one. Now, if you're using a calculator, there's really no need to convert radians to degrees. You just change the mode on your calculator and just type it in that way. I think converting radians to degrees is an extra step, a step you could make a mistake on. So, Ileana, could you tell me what my radius is here? 6. And my angle? Pi over 6. Now, using those two numbers you just gave me, could you give me my formula to find x?
6 cosine
Perfect. 6 cosine pi over 6. And Matt, could you give me my formula to find y? Do you have it written down? Yeah, just look right back at it, and just change r and theta to what they are in this problem.
6.
What's next?
Sine.
Yep, sine pi over 6. The only thing I want to be careful about now is when I type them in, put your mode on radians. Okay, so I'm already in radians. So I'm going to type 6 cosine pi over 6. And I get about 5.20, okay, if I round it. So that's my x value. And my y value is 6 sine pi over 6. Okay, I get 3. Okay, so when you write your coordinate, just write 5.20, comma 3. And what we really did is we just figured out the length of two sides in a triangle. The bottom side and the height. Any question on that? Okay, so what I'm going to do now is I'm going to graph the original point. Okay, I'm going to try to show you something. 6 pi over 6. What's pi over 6 again in degrees? 30. So I'm going to graph 6 comma 30. This part I just want you to watch and see what happens. So 6 and then 30 degrees. It's right there. Now what I'm going to do is I'm going to take a rectangular grid that's exactly the same scale as this one. Okay. So the first x value would be there, the second, third, fourth, fifth, sixth. So it's the same size scale. I'm going to drop that in on top of that polar one. The polar one will disappear, the rectangular one will stay, and this point should look like it's a little more than 5 units right and exactly 3 units up. Okay. So let's try that and see if it works. All right, so there's different scales. I just have to find, I think this one is large. Let's try it. Yep. So does that point look like it's a little more than 5 units to the right and exactly 3 units up? What do you think? But yeah, it ended up right where it should. So on a computer or any software where you can graph, if you can just change the background behind your point, you can quickly check if your answer is correct. Okay, but for that, you need some kind of software. So there's the point in rectangular. There's exactly the same point, changing the background behind it to polar. Any question on that one? All right. So let's finish up with trying that one on your own. If you don't have a calculator, at least get to the point where you set up your equation. and then we'll solve it together. All right, so let's see if we can get our formulas for x and y here. How about Victoria? What did you get for your formula for x?
I got 2.
Can you tell me what you typed in to get that?
-4 cosine 120.
Cosine 120? Yep. And did anyone else get 2? No. All right, so we get 2. Sometimes one of them comes out exact and the other one doesn't. Just depends on what you type in. And what did we get for, what's our formula for y? Yep, Alex?
-4 sine 120.
Sine 120. And what did you get for a decimal for that one?
Rounded to 2 decimals, I got -3.46.
3.46. So your coordinate is 2, -3.46. Let me show you how that answer could be written and how you could figure out that what I'm about to show you is actually just that. So, on the test, remember when we did unit circle trig, okay? Unit circle trig applied to any angles that were multiples of 30 or 60. Well, that's a multiple of 30. So there is a way to write that as an exact number with like a square root in it, either a square root of 3 or a square root of 2. So on the test, you might see something like, let's see, that would be root 3 over 2 times -4. So we could see something like 2 comma -2 square roots of 3. What I just wrote below it, that is the same answer, but that's the exact answer, not rounded. How did I figure that out? I did all the unit circle stuff we learned a few weeks ago. But if you don't remember that, all you have to do is take the answer that you would see on the test and change it to a decimal and see if it matches what you got. So type in -2 square root of 3, and when I hit enter, I'm going to get -3.46. Okay, so if you don't remember how to change it, just change the answer on the test to a decimal, and then it should match up with what you got. It might take a little longer, because if you have 4 choices, you'd have to change all 4, and then pick the one that matches yours. Okay? But any question on that idea? If something's written as an exact answer on the test, how to change it to a decimal to match it up to what you get. All right. Okay. I'm not going to go through graphing that one, but you could do the same thing. Plot the point, change the background behind it, and everything would line up nice. All right, so homework tonight. There is a little bit of graphing, so what I would do is I would just, by hand, or you could print it out, sketch one grid on your paper, and then you can just label your answers, like number 12, number 14. Okay. Just make one grid and sketch all the points on that same grid. Okay. So it's 12 to 26, 40 to 46. Just